very good evening to all of you. I hope I am audible and visible. So let's wait for at least 5 minutes so that any one of you can able to join this session. Okay, let's start our session. So, hello everyone, a very good evening. I am Pooja Verma and I am PPMR Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Computer Science Department, IIT Kharagpur. This is a live and interactive problem solving session of computer vision. So, this is the week 3. So, I hope all of you have gone through this week video lectures. So as a TA, we will solve some problems which will be similar to your assignment problems of this week. Okay, so can you confirm it whether I am audible and visible? Likhana, can you confirm it? Okay, so I hope I am audible and visible. Okay, so for this week, we have the course content for this week is camera geometry and how to place camera and what are the different projections related to camera. Okay, so let's move to the questions. So first question is, note perspective projective mapping is imaging the 3D world coordinates to an image plane using the projective camera where all the rays pass through a camera center. Consider the camera center is at 0, 0, 0 and the image plane is parallel to xy plane and at a distance of f from it. So what we need to calculate the perspective projective mapping from world coordinates world coordinates given as 1, 2 and 3 to image coordinate using camera with focal length f is equal to 0.5 is what will be the image coordinate from this world coordinate. So how we can solve this question? So first we need to see what are the parameters are given. Okay, so first one is given as a camera center, right, which is 0, 0, 0 and image plane is parallel to the xy plane and at a distance what is the focal length is 0.5 and the word points that are given is 1, 2 and 3. Word points are given. So how we will move forward with this question? So we need to calculate the image coordinates, right? So what will be the projective equations? So under the pinhole camera model, that is perspective projection, the mapping from the word coordinate to the image coordinate. So word coordinate, as you have gone this video lecture, so word coordinates is represented by here, let's say x, y, z. Now we have to convert it into the image coordinates. Image coordinates, that is small x comma y. So how we will calculate from this to this? The projection equation is given as x is equal to f x divided by z for small x and for small y it is f y divided by z, right? Here focal length, that is a distance from the camera f, is given as a 0.5 it is given, and here word coordinates is given as word coordinates given, that is x, y, z is 1, 2, 3. So x value is 1 in that equation, and you will able to find what will be the answer. So I will just wait for a couple of seconds, then I will solve it. And can you solve till now and answer in the chat box? So I have given the formula, just you have to put and let me know what will be the answer. Okay, so let's put the formula. So f value is given 0.5 and x value is 1 divided by z is 3. So what will be the value? 0.5 divided by 3, and it can be written as 1 by 6, right? Because 0.5 is 1 by 2, right? Similarly, we need to calculate y also. So 0.5 into 2 divided by 3. So if you just multiply 0.5 into 2, you will get 1. So 1 by 3. So what are the image coordinates? That is x comma y. It is 1 by 6 comma 1 by 3. Right? So which answer is the correct one? So option A is matching with this question. So option A is the correct answer for this question. Okay, so option A is correct for this question. So I will just remove it from here so that you can able to see all the options. Okay, so I hope you have understand this question. So can we move to the next question? Okay, so I hope you have understand. So move to the next question. So you want to, can I explain it once more, because some people are joining now. Okay, so here the question is given, we need to find out the image coordinate, where word coordinate and the camera with focal length is given. Okay, yeah, okay. So here, and the camera centered is also given. So now what we need to do, we need to convert the word coordinate to the image coordinates. So already, as we know that word coordinates are given in the capital X, Y and Z, and image coordinate is represented with small x and small y. So the relation between the word coordinates and image coordinates, also called a projection equation, under a pinhole camera model. Okay, so to map the word coordinates to the image coordinates, we have this relation: small x is equal to f into this capital X divided by Z, and y is equal to small f capital Y divided by Z. Here f is given focal length, f is given 0.5, and word coordinates are 1, 2 and 3. So that means x is equal to 1, y is equal to 2 and z is equal to 3. So now put the values of the in this equation, you will get the 1 by 6 and 1 by 3, that is equal to the image coordinates. So image coordinate x comma y is 1 by 6 comma 1 by 3. So from here we can find out the answer is the correct answer for this question. Okay. So okay, now I hope you have understood. So moving to the next question, because today we have much more calculations and we are solving it here in live, so it will take some time. Okay, so moving to the next question. Now next question is, if the principal point is located at 2, 3 in the coordinate system of the image plane, what would be the image coordinate of the word point 345 using a pinhole camera with focal length f is equal to 0.5. Here also the principal point is given, right? Word points are given and focal length are given. So again, how we can move with this question? Word points are given, focal length is given, and the principal point is given. Okay. So this is the principal coordinates or points in image coordinates. So I can write it. What are the? So it's better. Focal length f is equal to 0.5. Word length, that is x comma y comma z, that is given as 3, 4, 5. So x value is 3, y value is 4, and z value is 5. And the principal points, that is given, that is located at, it is, let's say it is represent cx comma cy, that is principal point, that is 2 comma 3. So perspective in the perspective projection, as we already know that before principal point adjustment. So using the first perspective projection formula, we will find out the image coordinate first. Okay, so already we have seen it, what is a formula for image to find out the image coordinates. So that is x is equal to fx divided by z, and y is equal to fy divided by z. To find the image coordinate, first we need to find the image coordinates. That is x comma y here. Okay, so first let's calculate. So what will be the value for x? Can you answer in the chat box? Please answer, at least solve it, and let me know what will be the answer for small x. Just put the values. Okay, so f is given again 0.5. Image coordinate for x, sorry, word coordinate, word length is 3, z is 5, right? So what will be the value? That will be here, will be the cancel out, you will get 0.3. Yeah, you can write, otherwise you can write in another way also. Okay, here already in points it is given, so it's better to represent in this form. Again 0.5 into 4 divided by 5.
0.4, ma'am.
Yeah, 0.4. Okay, so what image coordinates that we have got, that is x comma y is equal to 0.3, 0.4, that is. Okay, so now it is a simple image coordinates. So they are asking, actually they have also given the principal point. So we need to find out the image coordinate with respect to the principal point also. So now just add the principal point to the image coordinate. So you will get x final value, x plus cx. For y image principal point, you will get y plus cy. So x we have got 0.3, right? And the cx, we know that is 2, it is given, so you will get 2.3. Similarly here y also So y is given as 0.4 plus 3. So you will get 3.4. So x image you will get 2.3 comma 3.4. So which option is the correct one? So which option is
D.
the correct? Yeah, 2.3 and 3.4. So option D is the correct answer for this question. Okay. So if the principal points are given, that is located in the image coordinates. So first you need to find out the image coordinates, and to find out the image plane in that system, so just you add that coordinates into the principal point. So you will get the image plane, whole image plane values. Okay. Okay. So I hope you have understand. So moving to the next question now. So next question is, if the principal point px, py, focal length, orientation and camera center C of a pinhole camera are given as, so principal points are given 2, 3, focal length is given 0.5, and that orientation is given represented by R, is represented by this matrix, and camera center is also given 1 to 1 respectively. Then compute the 3 cross 4 projection matrix of P. So how we can compute the 3 cross 4 projection matrix? So to compute the projection matrix P of a pinhole camera, so projection matrix formula is projection matrix P is equal to, so K, capital K, R S of RC. So I think you have gone through this formula also in the video lecture. So where we know that K is the intrinsic matrix, and or already are, they have defined rotation matrix, or also here it is rotation or orientation. Okay, rotation or orientation matrix, and C already camera center. Okay. So what is a minus RC? What we can represent it? It is a translation. Minus RC, what we called minus RC, that term minus RC here. So minus RC, I'm just writing it here. So it will called as a translation vector. Translation vector. Okay. So now intrinsic matrix we have to calculate from here. Already with that we don't know. So how we can calculate the intrinsic matrix first? So first step is, I'm just writing one. First step, we need to calculate the intrinsic matrix, and other parameters we are given, it is given here. Okay, so from that we will calculate it. So first we need to calculate the intrinsic matrix. So how we can calculate? So for intrinsic matrix, so any one of you have remember how we can represent the intrinsic matrix K? So K is represented by this one, this matrix. If you have gone, so sorry, F, it is F, F0, that is principal point Cx, either Px, what here it is given as a in the form of Px, so I am writing, otherwise Cx also you can represent. Okay, 0 F Py and 0 0 1. Okay, so intrinsic matrix K is represented by this one. So already we know that focal length F, it is given, F is given, that is 0.5 here, right? And the principal points Px and Py is also given, Py, that is what is it? 2 comma 3 it is given. So just put and find out the what is the intrinsic matrix value. So f is 0.5, 0, here 2, 0, 0.5, here 3, value px is 3, and 0, 0, here 1. So here you have got the intrinsic matrix. Okay. So have you understand this one? How we can find out the intrinsic matrix? Now we will move further to solve that other question, other part also. So again, rotation matrix here it is given, camera center is given. Now first we need to calculate this translation first. Then we will able to solve this whole matrix K in brackets are given minus RC. Okay, so first and that minus RC term is called translation vector. So now next step is to calculate minus RC term, that is also called translation vector. Okay, so I'm just taking the another slide to solve that question. Okay, so now next step is to compute translation. So I'm just writing compute translation, that is denoted by T is equal to minus RC. So rotation matrix or orientation matrix R is given already, and C is also given. These values are given, you can see in the question. So I'm writing here directly. So minus outside. So R values you can just see in the previous slide. So what is it? 0.36, 0.48 and minus 0.8. The first row 0.36, 0.48 and minus 0.8. Now next value you can check, just I am writing here minus 0.8, 0.6 and 0, 0.48, 0.64, 0.6. Okay, and what is the camera center values? That 1, 2, 1 it is given in the question. Just camera center, see 1, 2, 1. Okay, so what will be the value? Can you calculate and let me know the answer? What will be the translation? So parallelly I am also calculating. You can also calculate. Okay, so just let's multiply row by column and add that. So first 0.36 into 1, so 0.36 itself. Similarly 0.48 multiplied by 2, so here 0.48 into 2. So again here plus minus, so I'm just directly writing 0.8 multiplied by 1. Okay, so now next one also 0.8 into 1 and 0.6 into 2 plus 0, 0 into 1. Similarly 0.48 here plus 0.64 into 2 plus 0.6. Further you will add all those values, you will get 0.52, 0.4 and 2.36. And just also take this minus value inside the matrix, so it will be the all minus. Okay, now we have got that value minus RC, right? It is also called extrinsic matrix, if you have seen. So it is also called this whole value, that is R given minus RC, or you can write R given T. It is also called an extrinsic matrix. So now T we have got. Now we have to represent in this form. So already rotation matrix is given. Already we know that 0.36. Here it is 0.48 minus 0.8. right? Minus 0.8, 0.6 and 0, 0.48, 0.64 and 0.6. Sorry, here that t, or we can directly you can write, so minus 0.52, minus 0.4, minus 2.36. Okay, so just I can okay, so whole extrinsic matrix are given to you or are given minus RC, you have find this whole matrix. Now what we need to calculate the final projection matrix P. So final projection matrix P, how we can calculate? Sorry, projection final projection matrix, already we know that it is represented by P. So K R given minus RC, so already we have seen in the previous slide formula, so you can also write R given T. So we have find out this value R given T, and K also we have calculated or we have got. Now we need to multiply these two matrix K and R given T. Okay, so it is a lengthy calculation or process, so I am just writing it here. You can calculate it parallelly if you have calculator, otherwise you can calculate it later also. Okay, so after this I am just writing it here. Okay, so here we have got this. So now next step is to calculate the final projection matrix. So just remove it from here. So just brain is not working. Start with the so can you write the till now these two K into these two matrices and calculate? Yeah, it's fine now. So let's P. So after that I'm writing here. Okay, after this one I'm writing it here. So extension that matrix K, what are the values? So it is 0 0.5, 0, 2, right? 0, 0 0.53, I think, yeah. 0, 0, 1. So this one, so 0 0.5 and 3. Okay. Now R given T matrix is this one. Just write it. So I have little bit less space. So 0 0.36, 0 0.48 and these values here. Okay, so just multiply by row by column. So here you can see that first row with this column, then you will get the first value. Now first row with this column you will get next value, like that. You have to just calculate it. Okay, so I am writing some values, you can calculate it, and then I will write the final projection matrix. Okay, so first, so I'm just showing 0 0.5 into 0 0.36. Okay, now next value is 0 into minus 0 0.8, so you will get 0 here, minus 0, so I'm directly writing where it is a 0. Now next is plus 2 into 0 0.48. Okay, 2 into 0 0.48. No, first row, then next one. So 0.5 into 0.48, again will be 0 plus 0 plus 2 into 0.64. Okay, now similarly first row, third column, this value, just you need to calculate like this. So I'm just taking the next value. So second row, first column, so 0, because 0 into 0.36. Now next one is minus 0.5 into 0.8 plus 3 into 0.48. So I'm just completing the first two columns, other you can just calculate it. Okay, so now second row, second column of this, second row of this, second column of this. Okay, so 0 plus 0.5 into 0.6 plus 3 into 0.64. Okay, next two columns you have to complete it. So now third row, first column of extrinsic matrix, so it will be the 0 only. Again next value will be 0, because 0 minus 0, 0. Now last one 1 into 0.48, so you will get 0.48 itself. Similarly for here also 0 plus 0 and plus 0.64. Now next two values you have to calculate it to complete this matrix. Okay, so if you just calculate and add all these values, so you will get here, just a minute, 1.14 here, next one 1.04, and next 0.48 itself. Similarly here 1.52, 2.22 and 0.64, right? 0.8, 1.8 and 0.6. Similarly here minus 4.98, minus 7.28, minus 2.36. You will get whole projection matrix there. Now if you match these values, so you will get from here option C is the correct 1.14, 1.04, 0.48. Here if you remove that minus RC here, minus, just these, just discard it to get. If in the options it is given here minus, so correct answer is this one. But if there is a no minus in every column is given, so you just remove that and just match, you will get the option C is the correct answer from this question. Okay, so have you understand this question, how to solve it? If these points are given, now you have to calculate the projection matrix. So first you need to find out the intrinsic matrix K value and calculate translation vector, and just put all those values in matrix form and just cross multiply with these two values, you will get the final projection matrix. Okay, so have you understand this question? Just you can match it here also. Yeah, from the last column, if in the options it is given, so you don't need to just discard it. So you can see from the options here no negative values are given in that, in any of that matrices. So you just simply remove that, and because all the values are matching, so that in the last column you can just remove this. Okay, okay. So if in the options that is there, the final correct answer is that one what we have solved, because there is I think no mismatch or calculation mistakes are there, so you can check it also once. But if there is, so you just match other options also. Okay, so final answer, if there is a no negative value, so that in that case you have to just discard the negative value to find out the correct option. Okay.
Madam, in this slide, P matrix is there, and we have to multiply with this projection matrix only, right?
No, we need to find out the projection matrix P, that is
Yeah,
the
okay, okay. But here 0.36, 0.36 and 0.48, what is this, ma'am?
this is already given in the question, that is a rotation orientation matrix, right?
Okay,
Where
we have to multiply
0.36.
with P and C only, right?
Yeah, we have to multiply with k and this value. So first we need to calculate the translation vector RC. Okay,
Mm, mm,
first. So R, it is a rotation matrix, it is given, and just we need to multiply. C is the camera center. So
okay,
all,
okay.
so just see in the, before we have solved, actually I have removed that part. So from
Mm.
there you can just check it. So you have to calculate by multiplying this matrix and this one. Okay, R into C, then you will get, that is also called T. Already told na, T is equal to minus RC,
Yeah, 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 okay.
translation vector. This is overall. So just you first you need to find out minus RC. Just put in this equation finally R given T. It is also said R given T.
No, ma'am. Next slide. I understood up to this.
Okay. So this
Yeah, here
equation.
multiplication P matrix is there, right?
Yeah, yeah,
And
exactly.
next, you were multiplied with which matrix, ma'am?
See,
0.36, 0.48, this matrix, right?
yeah, yeah, this matrix, because this is a minus RC matrix, na, or you can T, P
Okay.
matrix. Okay, this one. So this matrix is multiplied by intrinsic vector K, because
Yeah,
K.
but here you were right, 0.36 and 0.48, right? So that is the reason I'm confusing.
Okay, okay. So just you
Uh,
multiply first row, this column
yeah,
0.5 into
understood, understood,
0.36.
understood, madam, understood.
So just you, when you will just multiply, add and minus these values, you will get 1.14.
Okay,
So
okay, ma'am.
you just need to calculate all those values. Actually, I'm not able to calculate all those. So first two columns, this one I have here, it is written. Next two columns you can just multiply, add, and you will get all these values. Okay. So have you understand what is you are exactly asking? 0.36, 0. This matrix already given. It is given.
Yes, ma'am.
Okay. Okay. So now you have understand this question. So your doubt is clear now, right?
Yeah, understood, ma'am.
Okay, okay. So now moving to the next question. So now next question is question number 4. So here projection matrix is given. That is, consider projection matrix P. Here it is given. So evaluate the camera center in homogeneous coordinates. So now projection matrix is given. That is P 1 0 1 0 2 1 2 0 1 0 minus 1 1. So now we need to calculate or evaluate the camera center in homogeneous coordinates. Okay. So now camera center is defined as a null space of the projection matrix P. That is PC. If you have seen that, PC is equal to 0. Okay. Camera center is defined as a null space of the projection matrix P, that is PC is equal to 0. Okay. And now we need to, or we want to find out that is C, this is a camera center, X Y Z W. So such that P into C values we are putting here, X Y Z W is equal to, that is 0, or you also can write in the vector form. So you will get PC is equal to 0. Okay. Now the projection matrix, that is P, is given here, right? So just put and just multiply. P is 1 0 1 0 2 1 2 0 1 0 minus 1 1, multiplied with camera center value x y z w is equal to 0, right? This is equal to 0. Okay. So now just, can you calculate this one? Just multiply with this row, this column, this row, this column, and these values. So what you will get? Just, so x into 1x, 0 into y 0, so this part is 0, 1 into z w into 0, you will get 0. Next, similarly next row, 2x 2 into x plus y plus 2z 2 into z plus 0, right? Now next, x 1 into x plus 0, because 0 into y 0, and now minus 1 into z, so minus z plus 1 into w, so w is equal to 0. So just we can write it like this also, x plus z is equal to 0, 2x plus y plus 2z is equal to 0, right? X minus z plus w is equal to 0. We can write it like this in the form of equation. Now we have to calculate these equations and find out the values of x, y, z, w. Okay, so can you calculate it? How we can solve it further? How we can find out the values? So from here, first you can write it like this also, z is equal to minus x. Okay, here this equation can be written as, now put the z is equal to minus x here, you will get the in the form of x and y, or you will get any other values here. Now put in the next equation, then you will get the other values also. So I need to take the one slide so that I can calculate these values here. So what equations we have got? We have got x plus z is equal to 0, or otherwise we can write it z is equal to minus x. Just you can solve in any way. Okay. Now next equation is our 2x plus y plus 2z is equal to 0. Okay. So now we can put the value of this z here also. So 2x plus y plus 2z is equal to minus x. We have just find it here from here, equal to 0. So what you will get? 2x plus y minus 2x. Just if you rewrite it, so 2x minus 2x will be cancelled out. You will get the value of y is equal to 0 here. Okay, first value you have got, y is equal to 0. Now we need to calculate the next value. So next equation, our next equation is x minus z plus w is equal to 0, right? So now here also we can put the value of z, so x minus of x, right, plus w is equal to 0. So here you will get minus minus plus, so 2x plus w is equal to 0. So here we have got only y is equal to 0, so no y terms are there. So what we need to do? We can't, so we have to just take any value for x or w. So let's just take x is equal to 0. Let's say that, or you can just take any value, 0.5 I have taken here. Then what will be the values if we put 0 0.5 in this equation. So 2 into 0. Let's we have just taken this value, okay, to further solve this equation. So you will get 1 plus w, right? X is equal to 0 0.5. So what will be values? Okay, so w is equal to minus 1 we have got, right? Now similarly we will get the x we have taken, okay, so w we have got. Okay, so now we need to calculate the next value, z. So x is equal to 0 0.5, so z will be minus 0 0.5. Okay, just we have assumed this value. Let's take x is equal to 0 0.5. That's why, so what values we have got? X, y, z, w. This is center. So x value we have got, so just we have assumed that 0 0.5. Y is 0, we have by the solution we have got. Now z is minus 0 0.5. Next w is minus 1. Okay, so these values we have got 0 0.5, 0, minus 0 0.5 or minus 1. So first you need to go and check on the options whether there is any option. Otherwise what we need to do, we have to normalize these values. Okay, normalize these values or by multiplying entire vector by minus 1. So what values we will get? Minus 0 0.5, 0, 0 0.5 and 1. Just you will get the inverse values. So if you just normalize by multiplying the entire vector by minus 1, you will get minus 0 0.5, 0, 0 0.5 and 1. So now if you match that, you will get the value of B. Correct answer is C, B. It is matching with the option B. So have you understand this question? So anyone of you have any doubt?
Can you go back, ma'am?
Yes.
Just back.
Okay, here.
No, you are normalizing it by multiplying by minus 1.
Yeah, minus 1.
Why, ma'am?
So in the options you can check no options are matching with the minus 1. We have got 0 0.5, 0, minus 0 0.5, minus 1. So if you just carefully check by the options, then we need to normalize here. So it
Okay.
if
So
if
you mean to say that first we calculate the answer and then verify with our options?
verify with the options.
Okay.
If there it is there, then you can just tick it. Otherwise just you check with the options. I mean you have to just normalization is also taking the other step also. So just check with the which by which terms if you are normalizing you will get the answer, if you are just finding out that much of value. Okay,
Okay. Thank you, ma'am.
thank you. So anyone else? So can we move to the next question?
Yes, ma'am.
Okay, now next question is question number 5. Okay, so here also projection matrix is given. Compute the vanishing point of line in image coordinate with direction ratio is 5:4:3. Okay, so here again the projection matrix is given. Now we need to calculate the vanishing point of a line in image coordinate with this direction. So how we can move forward with this question? Any one of you have any idea? That 3D direction, let's see direction ratio is represented by D.
Instead of 0, we will take this one of 5. You take 0, 0, 0, no? So we take 5, 4, 3.
5, 4, 3. Yeah. What will be the equation for the vanishing point? Anyone of you had any idea? Okay, so if you have gone through this video lecture, so there vanishing point of a line in a given direction D is the projection of a point in an infinity along the direction V. This is the direction of that vanishing point. It is represented by BVD. Okay, this is in the direction. So we can say that projection matrix P into dx, dy, dz and 0, and thus 0 is represented point at infinity, right? Point at infinity. So now the this D is represented with the point, so 5, 4, 3, 0, right? So now vanishing point V we can calculate by this equation P into D. So here projection matrix P is given. So what is the projection matrix? 1 0 1 0 2 1 2 0 1 0 minus 1 1, and this vanishing point image coordinate with direction this one 5 4 3 0, right? Now first we need to calculate V. So can you multiply and give answer for this multiplication? So you will get 1 into 5, 5, then next 0 into 4 will be the 0 only, 1 into 3 is 3, now next 0 into 0 will be 0 there. Now next similarly 2 into 5 you will get 10, 1 into 4 is 4, 2 into 3 is 6 plus 0. Now next one is 5 plus 0, now minus 3 plus 0. So V you will calculate like 5 plus 3 8,
8.
10, 20, right? And next is 5 minus
2.
3, 2. Yeah, right. 2. So now you have got the vanishing point, but already we have just added the point at infinity. So now if we convert it again to the image coordinates, so already we know that if image coordinate is given in the form of x, y, z, so to convert it into a 2D image plane, so what we are doing, x divided by z and y divided by z, right? So similarly what we need to do here also, 8 divided by 2 and 20 divided by 2. So it is already in the 3D image coordinates. Now again we need to convert it into 2D. So you will get 4 into 10. So final image coordinates in the vanishing point of line in image coordinate with this direction we have got 4 10. Okay, so option C is the correct answer for this question. So here we have just calculated into the 3D plane or point at infinity in the homogeneous form. So now next we again convert back into a 2D image plane. What we are doing in the, we have I think seen in the first week of video lectures. So here again to convert it, just we need to divide by the third term, first two term. So again we will get 4 into 10. Okay, so have you understand this question? So have you understand this question? Any one of you have any doubt? Okay.
It's understood.
Okay, so now moving to the next question. question is again, consider a projection matrix P. P is given. Compute the camera center C in homogeneous coordinates. So now again we need to compute the camera center in the homogeneous coordinates. So how we can solve it? This question, only projection matrix P is given. So how we can move it forward? With this question, so already we have seen in the lectures that projection matrix P can be represented in this form also, M given P4, right? It is also written in this form. Okay. So the camera center is at null space P. Already we have seen that the camera center is the null space of P, that is already seen in the previous question. One of the PC is equal to 0, right? And the C we have also seen here, the camera center we need to find out. So let C is equal to x, y, the coordinate of is W transpose, right? So already we know that P into C is equal to 0. So just projection matrix here it is given. So just P and C, multiply it. So I'm just removing it here, already written. So just take a projection matrix 8, 5, 4, 0, 7, 8, 9, 0, 1, minus 5, 8, 1 into x, y, z, w is equal to 0. So now from here again you will get the equations in the form of x, y, z, w. Then again you have to solve these equations. Okay, so any one of you can let me know what will be the equations, what equations here we will get, what equations we have formed here. Okay, so I'm writing it here. So 8 into x, 8x plus 5y plus 4z is equal to 0. Similarly, just next row, this column, you will get 7x plus 8y plus 9z is equal to 0. Now next one is x minus 5y plus 8z plus w is equal to 0. So these three equations we have derived from this equation. Equation 1, 2, 3, you can say that. Now we have to solve these equations. So how we can move forward? If you have calculator, so you can solve these two equations. No, you can't solve. So just take any one of these and calculate it. So I don't have any extra slides, so let me add just one extra slide so that we can solve it. Okay, so three equations we have got. So let's, from equation 1 we can rewrite that equation in that form. Also x is equal to minus 5y minus 4z divided by 8, because the first equation is here 8x plus 5y plus 4z. So just if we here 8x is equal to, we can write like this, minus 5y minus 4z, right? Now further if you solve it, so you will get minus 5y minus 4z divided by 8, right? So that we have written, I have written here minus 5y minus 4z divided by 8. Let's say it is equation 4. Okay, now put this x value in equation 2. Okay, put equation, put the value of x in equation 2. So you will get 7. In the place of x you will get minus 5y minus 4z divided by 8 plus 8y plus 9z is equal to 0. So just if you calculate this equation, you will get minus 35y minus 28z plus 64y plus 72z, right, equal to 0. Now if you further just add, because we have got in terms of y and z only, so further you solve it, so you will get 9y plus 44z is equal to 0. Now again you can take any one of, in terms of any one value, so minus 44z divided by 29 you will get, right. So let's say it is equation 5. Okay, now put this y value in equation 4. Okay, put the value of y in equation 4. To solve this further, x is equal to minus 5 and minus 44 z divided by 29 minus 4z divided by 8, right. So here you will get, if you final just do calculations, 104 z divided by 232, it is a z. Okay, or you further just cancel out some term, you will get 13z divided by 29. So let's say it is equation 6. Now what we need to do, we need to put the x, y, what we have got, x, y and this z value in equation 3. All those values what we have derived here, just put in the equation 3. Put the values of x and y in equation 3. Okay, so if you put all these values x, y, so in the equation 3 it is in the x minus 5y plus 8z plus w, right. So here you will get minus 5y minus 4z divided by w minus 5 44z divided by 29 plus 8z plus w, right. And again the put the y value here, or you can directly write the x. Okay, x we have solved, so directly in the place of that you can write 13z divided by 29, right. So I'm just removing from here so that we can solve it, these values. So here little bit calculation mistake is possible, so I would suggest all of you please just cross check and calculate by yourself also. Okay, so further what we can write whole equation 13z divided by 29 plus 220z divided by 29. Here if you just do that, plus 8z plus w equal to 0. So now if you just solve this, or you will get minus 4 465z divided by 29. So w value you will get the minus 465z divided by w. So to find the homogeneous coordinates, to find homogeneous coordinate, already it is in that form. So just we have to assume any one of value, because all the x, y and w values we have got in terms of z, right? Now let's assume that z is equal to 1. Okay, then you will get x, let's put in equation. So x is equal to 13 z divided by 29. So you will get here 13 divided by 29, right? And the y is minus 44 z divided by 29. So you will get minus 44 divided by 29. Similarly, w is minus 465 divided by 29, right? So now just divide, you will get further, you will get the values of the 448. Here you will get minus 1.517. Here also you will get minus 16.034. Okay, so I just need to remove these. So I hope all of you have noted down. So I'm just removing it from here so that we can further solve it. Okay, so what values we have got? Center C values, that is x, y, z and w, right? So x value what we have got, 13 divided by, I'm just writing in that form only, minus 44 divided by 29. And z we have assumed that z is equal to 1, and w what we have got, minus 465 divided by 29, right? So to normalize these values, to put w is equal to 1, because the so to normalize these values, what we, because w is 1 here, so what we need to do, the last term should be 1, right? So what we need to do, just divide all these values by minus 465 divided by 29 to normalize these values. So can you divide and let me know what will be the values? Yeah. To normalize w is equal to 1, that means this value, what we need to, we again divide all these values to minus 465. So divide all by minus 465 divided by 29. So just if you divide that, so what values are left, you will get here minus 13 divided by 465, right? Here also, so minus minus plus will be there, so 44 divided by 465, because 29 will be cancelled out, and here also, here you will get 29 divided by 465, right? And comma 1, minus here also, minus will be here. So now if you just divide all these values, so you will get minus 0.028, 0.0946 and and the next value I am writing it here, minus 0.0624 comma 1, and just go and match with the options. So you will see which 0 point is 0.028. So I think which option, 0.9, yeah, 0 minus 0. Option C is matching with this answer. So okay, I hope you understand this question. To solve this, so anyone of you have any doubt? So moving to the next question. So many calculations are there. So yeah. So just you have to keep one calculator also, so that calculations will go smoothly. And that much speed is not possible. You can solve it later. I have it. That's why I have solved it before, so that it is easy to just calculate these values and showing how to calculate. So now moving to the next question. So now next question is a projective geometry, a projective camera P, that is projection matrix, is given. Image a 3D line L as represented by small l 1, 2, 3. Compute the plane formed by projected line L and a camera center. So here the image line L is given, that is 1, 2, 3, and the projection matrix P is also given. So how to compute back the projected plane with the camera center? Camera center, I think next question is also based on that. Okay. So here only these options are given. So okay, image line, that is 3D line L as L is given. So image line L is given 1, 2 and 3, and projective camera, that is projection matrix, is also given 8, 5, 4, 0, 1, 8, 9, 0, 2, 1, 1, 0. So compute back, that is the plane formed by projected line L. So how to calculate? So the formula for that compute back the projected plane, that is represented by pi. Okay, that computed projected plane is represented by pi. It is calculated by P transpose L. Okay, so here projection matrix P is given and L is also given. So just we need to multiply these two matrices. So first we need to take the transpose of that projection matrix. So what will be the value of that P transpose? What will be the matrix? This is a 8, 1, 2. Just change with the row, column and column to row. 5, 8, 1, 4, 9, 1 and 0, 0, 0, right? And here it is 1, 2 and 3. Okay, P transpose N. So now again just row into column matrix multiplication, just calculate it. So 8 into 1, 8 only, 1 into 2 is 2, 2 into 3 is 6, 5 into 1 is 5, 8 into 2 is 16 and plus 3. again 4 plus 18 plus 3, right? On and next one is 0 plus 0 plus 0. So here you will get 16 and 24, 25 and 0, right? 16, 24, 25 and 0. So this is it. Compute the plane formed by projected line L and camera center. So this is the line that is formed, that is plane projected line L and camera center. So take this one. So you can see option A is the best matching from the answer. Okay, so it is directly formula based. So just you need to calculate P transpose L. Okay, so I hope you have understand. So now moving to the next question. Okay, so now next question is, consider that the camera projection matrix P is given two image points x1 and x2 and the camera center O. So two image points are only given, x1 and x2, and camera center represented by this O is given. Find the unit normal to plane OX x1 x2. So now we need to find out the unit normal to plane O x1 x2. Okay, so let's see. So what are the values given? Projection matrix P is given, and x1 and x2, the image points in the 2D, and H0 is the camera center, it is also given. So now in the each 2D image point, let's say x is equal to UV corresponds to a ray containing the point that is O and having image coordinates UV. In the homogeneous coordinate system, the image points is represented by, already we know that in the homogeneous coordinate system, the image points is represented by UV1, right? So already we have seen that the 3D back projection plane equation is back projection plane is represented by, that is phi is equal to P transpose x. So here I am taking that phi x because here 2 points are given, x1 and x2. Okay, so we need to calculate phi x1, phi x2 also. Okay, and x is the homogeneous 2D point, it is also given 2 image points. So first x1 and x2 we also need to just represent in the homogeneous coordinate system. So for x1 it is represented by 3, 2, 1, right? So first we need to calculate pi x1. So what we need to do, first transpose this matrix P transpose we need to take. So 8, 5, 4, 0, 1, 8, 9, 0, 2, 1, 1, 0. With this 3, 2, 1. So from here you will get the pi x1. Similarly we have to calculate the pi x2 also, or you can represent it phi 1, phi 2 also, whatever suitable for you, for your understanding. Okay, so just can you calculate and let me know what will be the values of the matrix? So first 24, 8 into 3 plus 2 plus 2, right? Now next 20 plus 16 plus 1. Next one is 12 plus 18 plus 1. Next one is all values are 0, so I'm directly writing it 0. So just if you add all these values, so you will get 28, you will get 32, no, 30, 20 plus 30, 36, 37 will be there, something. So here 5, 15, 16 plus 32 is the correct, and next one is 31 and 0. So pi x1 you will get 28, 32, 31, 0. So similarly we have to calculate pi x2. So I am just going to the next slide to calculate the next value. So pi x2, so p transpose x2, so p transpose, next value is x2, right? So just take pi transpose 8, 1, 2, 5, 8, 1, 4, 9, 1, 0, 0, 0. The next value is 5, 7, 1. So image point is 5, 7. So in the homogeneous coordinate representation, the value will be 5, 7, 1. Okay. So now you will calculate pi x2. So I am just directly writing. So 40 plus 7 plus 2, right? 25 plus 56 plus 1. Now next is 20 plus 63 plus 1, and next is 0. So if you further add these values, you will get 49, 82, 84 and 0. Okay. So are you solving this question? So pi x1 and pi x2 values we have got. So now what we need to do, it is a little bit lengthy question. Okay. So here P matrix is given, right? So here some theoretical concepts are there. So as we know that we need to find out plane through O x1 x2, right? So pi 1 is the plane through that O, and the ray is for that is x1, and similarly pi 2 is the plane through that center O, and the ray of that is x2, and the intersection of pi 1 and pi 2 is the line OX1 and OX2. Okay, so that the plane containing OX1 and x2 is formed by the cross product of the plane normal in the 3D space. So in the dual form, the plane normal in the 3D is given by the cross product of the direction of the ray of the x1 and x2. So the ray direction is found from, so the ray direction is found from M inverse x. Okay, so already we know that the representation of P, that is M given P4, so that this matrix is given this one, so P, so this part is M, this is a P4, right? So just write the P M. So M given, so I am not writing the whole P matrix again. Now we need to just on directly writing here M. So already I have just told in the previous slide. So what will be the values of M matrix? 8, 5, 4, 1, 8, 9 and 2, 1, 1. So 8, 5, 4, 1, 8, 9, 2, 1, 1. So now to find out the ray direction in that form, so we need to calculate M inverse also. So to calculate M inverse, what will be the, how we can calculate the M inverse? That is joint of M given by determinant, right? Determinant of M. So how we calculate the adjoint of M? So this is a cofactor of M transpose, cofactor M. Just find out all the cofactors of that matrix M and transpose that matrix. So let's first find out the determinant of the M. So can you calculate the determinant of that matrix M? So this is little bit lengthy question. So any one of you calculating this question? Okay, so let's calculate. So already we know that 8 minus 9, then minus 5, then just multiply these two, 1 minus 18 plus 4, just take this first row and last column out and just cross multiplication of this, 1 minus 16, right? So determinant of M, if you further just calculate directly writing, you will get the 17. Okay, so overall determinant of that matrix M, you will get 17. Now calculate the cofactors also. So cofactor, so I have just calculated. So I recommend you all for better practice in the exam, just practice this type of question more, so that your speed will be the enough for the exam, in the exam. So just calculate all the cofactors. So I have calculated. So here you will get 1 minus 1, 17 minus 15 minus 1, 0 and minus 1, here minus 37, yeah, minus 10 and 59. Okay, so now just take a transpose of this cofactor. I can take a new slide. Okay, so to find out the joint of M, transpose of all the cofactors, so you will get minus 1, minus 1, 37, 17, 0, minus 10, minus 15, minus 1, 59. Okay, so to final value of M inverse, you will get 1 by 17 and this matrix minus 1, minus 1, 37, 17, 0, minus 10, minus 15, minus 1 and 59. Okay, so now we have to calculate the distance from B1. Let's say for x1, distance from that x1, so it is represented, let's say D1, so you will get 1 by 70 and this minus 1, minus 1, 37, 17, 0, minus 10, right? Yeah. Minus 15, minus 1 and 59. So x1, what are the x1 values? 3, 2, 1. So to calculate distance from O x1, and then again we have to calculate the D2 also, M inverse x2. So you will get the distance D1 and D2. Okay, so just if you multiply and add these values, you will get here minus 42, 41 and 12. Okay, just minus 3, minus 2 and 37. So you will get 42 minus 42. Okay. Something special here. Okay, here minus 37 is there. Okay, just let me check once. Yeah, here minus 37 is there. So just okay, so it is minus 37 over there. So I have just misplaced the minus value. So overall you will calculate, you will get minus 42, 41 and 12. Similarly, the distance from for x2 we need to calculate, that is d2. So 1 by 17 minus 1 minus 1 minus 37, 17, 0 minus 10 minus 15 minus 1, 59. The points of x2 is 5, 7, 1. Okay, so further you will calculate what will the values you will get. Minus 5, minus 7 and minus 37. Can you add and let me know what will be the values? So you will get the value of d2. So you will get minus 49 here, then 75 minus 23, right? So any one of you are you getting this question? So much calculations are there. So now what they have said, that is cross product of the normal, that is n is equal to d1 and d2. So now we have to take the cross product. So here you can say that the both in the d1 and d2, cross product for normal n is equal to d1 into d2 we need to find out. So the factor 1 by 17 we can remove because it is redundant. So by removing 1 by that, you will get the values minus 42, 41 and 12. Let's say it is represented by dash values. So for the easy multiplication purpose, that's why. Otherwise you can take this 1 by 17 also. Okay, so I think that much of lengthy question in the exam should not come, but in any case if it is coming, so you should know how to solve this question. Okay, so d2 values is 75 and minus 23. Okay, so how we can find out the cross product of d1 and d2? So already we know that. I say okay, we can find out by this one. Minus 42, 41 and 12 minus 49, 75 minus 23. Okay, so if you will calculate, you will get I 41 into minus 23 minus 12 into 75, right, in one bracket. So minus j, that is 42 into 23. So here minus will be plus. So again here minus will be plus. So on directly 49 into 12 plus k. So here minus 42 into 75 plus 49 into 41. So it is a very large values you will get. So finally I am writing it here. So I here you will get minus 1843 minus j, you will get 1554 plus k minus 1141. So you will get minus 1843 minus 1554 and minus 1141. To normalize these values, so to find out the unit normal, what is the formula for the unit normal? That is n tilde is equal to n divided by n, right? Now this n, to normalize, how we calculate? Root of that 1843 square plus 1554 square plus 1141 square. So if you calculate this value, you will get approximately 2667.6. Okay, now further you have to calculate the unit normal of that cross product of the D1 and the D2. So you will get minus 0.6909 minus 0. Sorry, 0. Just a minute. So you will get minus 0.5825 and minus 0.4278. Okay, so this unit normal, and further you can normalize it also. So this value that we are getting, so exactly I think it is not matching with this, otherwise option C is the correct answer. Just you can cross check it once. This is a procedure to solve this type of question, to find out the unit normal to the plane x1 and ox1 x2. Okay, here option C is the correct, but exactly my answer is not matching. So much calculations are there, so just you go and check with one. This is the formal procedure. Okay, okay, so now we will moving to the next question. So I hope have you understand this question? All of you have understand this question? Can we move to the next question? Okay. Okay. So now next question is camera intrinsics f is then focal length, that is called a focal length. Also f is equal to 2 is given. Principal point cx and cy, that is given 1 1. Rotation, that is r is equal to identity matrix, that is I is represented by I. Now camera center C is equal to 0 0 5, it is also given. Now they are saying the build the 3x4 projection matrix P. So already we have solved one question like this. So now can you tell me how to solve this question to build the projection matrix P from the given point? So already I have told you the projection matrix P is represented by matrix P is represented by K, that is the intrinsic matrix, and in brackets R given minus of RC, and it is also represented by K into R given T, where T is the translation vector and T is equal to minus of RC. Okay, here C is given, R is given, that is a identity matrix. So what is the value of identity matrix? 1 0 0 0 1 0 0 0 1, right? So R is equal to I, that is identity matrix, already we know that. So now how we can calculate this K value? K is called intrinsic matrix also. Intrinsic matrix K, the values of this is F 0 Cx 0 F Cy and 0 0 1 to calculate the intrinsic matrix K value. So now F is given here already, so 2 0 Cx is also given, that is 1 0 to 1 and 0 0 1, right? So k we have got. Now we have to find out the r given t, right? So r given t, so t is equal to minus rc, right? So no, first we need to calculate minus rc. Okay, so r is equal to I, already we know that. So yeah, directly we can get. So I is equal to, it is given, so r given t we can directly calculate. Okay, so any calculation does not require, because it is r given t. What will be the values of r given t? So that r is equal to I, so 1 0 0 0 1 0 and 0 0 1, right? And what will be the t? Minus rc, so r into c, 0 0 5. So what value you will get? You will get only 0 0 5, right? 0 0 minus 5, because minus of rc. So just we can, t is equal to minus of rc. R is identity matrix, c is 0 0 5. Should I need to calculate, or I can write it directly? It is understood. So minus of rc value you will get 0 0 minus 5. Okay, in this form you will get. Let's calculate it. Minus of rc, so r value is 1 0 0 0 1 0 0 0 1, and the c is 0 0 5, right? So row into, so first value you will get 0, because 0, then 0 0, so 0. Next one is also 0 in the last, because 0 0 you will get 5 here. Here minus value because of here minus. Okay, so minus t is equal to minus rc. So r is here, and here you will get 0 0 minus 5. So now it is understood how we will got the r given t. Okay, so now we have found the k values and r given t values, so we can calculate directly the projection matrix. Okay, so can you multiply and let me know what will be the values of that projection matrix? Otherwise I have to remove it from here. Okay. So I'm removing it from here to calculate it. Projection matrix P is equal to K into R given T, right? So just we need to multiply these two matrix. Okay, so row into column, row into column. Let me write it here, otherwise it will be very confusing. So 1 0 0 0 1 0 0 0 1 0 0 minus of 5. So can you calculate it and let me know what will be the values of that projection matrix P? So it is P is equal to K R given T. So K values we have got, R given T value we have calculated. Now can you let me know what will be the value? So in the first row you will get 2, right? Here only, so 2 into 0 into 0, so 2 only. So parallelly you have to calculate all those values. You will get 2 0 0 here also, 0 2 0, and here you will get 1 1 1, and in the last, because all the 1 also minus 5 and minus 5 you will get. So this is the overall projection matrix if you multiply these two matrices. Okay. So I think you have understand. This is a simple problem already we have solved. this type of question previously in detail, so I have solved it here. Just you have to do the calculations. Okay. Okay, so now moving to the next question. Now next question is using the projection matrix P from the question number 9 in the previous question. What we have calculated, that projection matrix, the projected point X.
Can you show me the answer again, our last question?
Yeah, sure. Yeah, this one. Yeah, is it fine?
Yeah, ma'am.
Okay, so can we move forward? Just you have to do matrix multiplication. It will take time, so that's why I have not gone into detail. Simple matrix multiplication. So I think you can solve it. So I have directly that's why written. Okay, so now using this projection matrix for the next question, we have to calculate the image coordinates. Okay, so the projected point X is given, that is 1 2 6 1 transpose. So image coordinates is calculated by, just I'm writing the formula, image coordinate, let's say it is x dash, is calculated by, this is x dash is equal to p into projected point. So projection matrix we have calculated previously. So it is 2 0 1 minus 5 0 2 1 minus 5 0 0 1 minus of 5, and x is, it is also given 1 2 6 1. Okay, p into x dash. So now can you calculate this matrix point and let me know what will be the values. So 2 into 1 2 plus 0 1 into 6 is 6 minus 5. Okay, now next one is 0 plus 2 plus 6 minus 5. Now next one 0 plus 0 plus 6 minus 5, right? So here what you will get 3. Now next one 6 to 8 minus 5, again no, it is 2 to the 4. Okay, yeah, some mistakes. 2 into 2 4, 1 into 6 6, yeah, 10 minus 5 5, you will get here, and here 1. So already, as we can see, it is a homogeneous form of image coordinate. Now convert back into 2D, convert back into 2D image coordinates. What we need to do, let's say it is x dash and y dash, so we can find out 3 by 1 and 5 by 1. So you will get 3 into 3 and 5. The image coordinate from the above, using the above projection matrix P and that projected point X, you will get 3 and 5. Okay. Okay, so have you got this question? Okay, so I hope you have got this question. Now moving to the next question. Okay, so here in the next question, the projection matrix P is given. Now they are saying that find vanishing point of the direction D. We need to find the vanishing point in the direction of D. So projection point P is given and direction D is given. So to calculate the vanishing point, it is represented by P, D and 0. So already we know that this is a 0 represents the point at infinity. Already I think one question we have solved on that. So that now again we have to just rewrite this projection matrix in the form of M P4, right? So that how we can represent, so or you can say that all these values, so these values are point at infinity, right? So now we can write, just remove the point at infinity, so we can rewrite the projection matrix 1 0 1 0 1 2 0 0 1 in that form, right? Or we can write the projection matrix in this form also, D comma 0, right? So yeah, this one is not that projection. Yeah, so to calculate the vanishing point V, this is a P into T. So by removing the point at infinity you will get this one. So now calculate the P into D to get the vanishing point of that direction. So you will get 1 0 1 0 1 2 0 0 1 in the direction of 2 1 1. So it's again simple matrix multiplication. You will get 2 plus 0 plus 1 0 plus 1 plus 2 0 plus 0 plus 1. So here you will get 3 3 and 1, and again it is a homogeneous form, so convert back into the image plane or vanishing point in 2D. So you will get 3 3 because 3 by 1 3 by 1, so you will get the vanishing point is 3 3. Okay, so I hope you have understand. So moving to the next question, because we are running to the time. So next question is also very lengthy. Yeah, so the next question is also given the camera projection matrix P, and now we have to again compute the camera center C in the homogeneous coordinates, right? So how we can calculate it? So already we have seen that if projection matrix P is given and the camera center C is represented in this form X, Y, Z, W transpose, right? And P into C is equal to 0, right? Already we have seen this one. So how we can calculate further? And also we know that P is equal to M given P4, right? This part is M, it is represented by P4. Okay, and the camera center, that's why here it is not given. Okay, we have already solved this question. Yeah, we have solved. Okay, so is it already solved? So I think we have repeated this question. Okay, let me check. Yeah, it is already solved, question number 5. So I am not repeating it here again. So mistakenly I have taken the same question. So already it is solved and time is also. So if anyone of you have any doubt, so you can ask, otherwise we can close the session. So thank you everyone, thank you for joining this session.
Can we get the recording of this session?
Yes sir, you will get, I think there is a one link in the recording sheet you will get in that lectures you are getting from where week wise in the swam portal. So from here one live recording session, one section will be there, otherwise you are also getting email recording feedback. So from there is also one recording sheets will be given. Let me just show you.
Okay,
You
thank
will
you.
get this type of email. So so have you understand where from where, otherwise you can also subscribe the channel link, I can show you.
Ma'am, can you show me the answer of last question again?
Okay, so last question is same as
Yeah,
a
just you
fifth
skipped,
question.
huh?
So last question is same as a fifth question. Okay.
Okay, okay.
So fifth, no, question number 5. Okay, let me show you. No, it is a sixth question. Yeah, question number 6. Answer is C. This one. It is the same question after this. So 6 and
Just
12
hold on,
also.
just hold on a minute.
Yeah.
Okay, ma'am, thank you.
Okay. So I'm just giving you a YouTube link also. From there you will get all the recordings of my video lectures and the recording sheet link also. So from this link you will get the recordings of the all the TAs as well. So when you will open this link, let me just present all. So okay, I think you are now able to see whatever. So from here, that is PMRF computer vision, it is a recording sheet. So here you will get, here the last one is mine. So here your presentation folder link, it is there. So all the PDFs and everything whatever we are, the questions you will get from here, and also YouTube link are provided here. So all I will upload it after some time. So you will get all the from recordings and the questions from here itself. Okay.
Ma'am,
Okay, so thank you everyone, thank you for joining. I think this session will be the helpful for solving your assignment problems. So should I am going to a very difficult or difficult questions, are, or you want same type of question or some easy problems? Is it fine for you guys? Actually I am not going through that summary session type. I'm not going through the concept, and I'm directly solving the problems here, because if I am going through the summary session or some concepts, then we will not able to solve the problems. I think then we will hardly we are able to solve only 5 questions, because the questions are very lengthy itself. So is it fine for you guys, or should I improve anything else? Okay, so you
things
will
are good, ma'am.
It's fine, ma'am. We don't want theory because theory we
yeah,
can read.
is already you are studying, all the
Yeah.
lectures are there. So okay, I'm going questions only. Is it fine? It is hard or I mean easy, something like this?
Sometimes it is lengthy.
Yeah, is it length? But the questions are like that only. We can't do anything.
So can you imagine, suppose in an examination hall, in we get a 2 minutes. So can we do in 2 minutes these calculations?
In that case, this is a previous year questions only I have taken, but it is little long back, so I am not taking the just previous year assignment because the questions are same. So I am taking the questions of 2019. So I think you will get the ideas which type of question they have asked. So they are asking this type of question. In that case, they will give time, some time, some more time will be given, or just
Ma'am,
we will do practice itself. Yeah,
one
please.
general question not related to subject or this session. Already I have done payment, but I am getting mails and messages through WhatsApp also. Not registered. Please register for the exam, like that. So how to know my registration has been completed or not?
Okay, so just go to the Swayam portal where you have registered. If you already registered, payment has been done. So I think there will be, it is showing that you have already registered. Maybe you will get mail. But if you have already you got any confirmation related to that, yeah, your payment has done or something receipt type.
Yeah, at the time of payment, I have received mail.
Okay, okay. So that's fine. That is okay. Actually, they are sending the email to all. So I think that's why
Okay,
you
okay.
are getting. Otherwise, you just cross check it. Just log in into the
In the
portal
Swayam
and
portal also, I am checking every day. My payment,
you have
payment
registered.
already. Yeah, okay, okay,
Okay,
ma'am. Thank
you have registered that means that is not a problem. Okay, okay. So thank you everyone. Thank you for the joining the session. Now we can close the session. Any other doubt? Anything else?
No, ma'am. It's thank you very much.
Okay. Thank you everyone. Thank you for the joining the session. You can leave the session now.